Hello everyone, today we will talk about instantaneous velocity. What is instantaneous velocity? This is a velocity at single instant of time. What does it mean, single instant of time? We will explain it here. So let's assume we have a car. This is initial point, let's call it point 1, and this car is moving to the right. Initial velocity, let's say, equal to 2 meters per second. After some time, when let's call it t2, after, or just let's call it time, after time 2 seconds, velocity becomes, let's say, 3 meters per second. This is the initial time when time was equal to 1. Time 0 is at the left side, for example. Somewhere here, let's say when time was equal to 9 seconds, velocity was equal to, let's say, 50 meters per second. So instantaneous velocity, basically velocity when time was equal to 1, equal to 2 meters per second. 2 meters per second. Yes, at this time. So we call this one as instantaneous velocity at 1 second. And instantaneous velocity when time was equal to 2 seconds equal to 3 meters per second. Because this is a velocity when time was equal to 2. So we call this one instantaneous velocity at 2 seconds. This is a instantaneous velocity at 1 second. This is a instantaneous velocity at 9 seconds. So this is a definition for instantaneous velocity. So basically instantaneous velocity at certain time. Basically when you have a motion with varying velocity changing, then instantaneous velocity, it means velocity at certain time. So you should also give time, let's say time velocity after 10 seconds after starting motion, we call it instantaneous velocity at time 10 seconds, instantaneous velocity at time 20 seconds, etc. So let's explain it in terms of graph. Let's draw position time graph, position and time. Here we have a 0. So let's say we have this kind of graph. We know that this is a motion with constant velocity, yes, because this is a straight line. So velocity is constant here. Uniform motion, we call it. So what is the instantaneous velocity, for example, at 10 seconds, for example? And what is instantaneous velocity at, I don't know, for example, 3 seconds? Since this is a uniform motion, velocity at all time equal to each other. So instantaneous velocity here, same at 3 seconds, also at 10 seconds. What if we have a different motion? Again, let's draw position time graph. Here we have 0. Let's say we have this kind of graph. What does it mean? This means we have a motion with varying velocity. Velocity is not constant anymore. It's always changing. And it's obvious that velocity at point here, 0, because position is 0, and velocity is increasing. Velocity at each time is different. And let's number it. Let's say this is 0, 0.1, 0.2, 3, 4, 5. And we know that velocity at 0.5 is greater than velocity at 0.4. And the velocity at 0.4 is greater than 3. Velocity at 0.3. V2, V1, V0. So V5 is the instantaneous velocity at time T5, let's call it. So how we can find velocities at different times, because velocity is changing. what we can do. Here you should remember about derivative. Here you should remember about derivative. Derivatives. Derivative, you need to remember. What is a derivative? So actually, definition of velocity is derivative of x is derivative of displacement, distance, with respect to time. So this is a definition for velocity. So this is what you should use to find instantaneous velocity. So the derivative of displacement, distance, with respect to time. And we call it derivative, yes? Velocity is derivative of distance, displacement. And now here you should remember about derivative. So each line has its own mathematical definition. It can be, each line can be described by mathematical equation. For example, this one has a mathematical explanation in terms of mathematics. We can say x equal to 10 times t. Yes, this is a linear equation, for example. This one also has a mathematical explanation. For example, 5t square. Yes, this is just example. So when you take derivative of this equation with respect to time, it will give you velocity. Here same, when you derivative of this equation of this x with respect to time will give you velocity. So here you need to remember about derivatives. For example, let's find velocity, instantaneous velocity for the second graph. Equation for x is given for position. For example, let's say it's equal to 5t square. So derivative of this equation with respect to time, 5t square delta t, or sometimes we write it in this way, yes, 5t square, like this. We are talking about the same explanation. So we know that 5 we need to multiply by power, which is 2, and the t 1 minus 2 minus 1 power. So velocity equal to 10t. This is equation for velocity. Now you should be able to study this kind of equations. What this equation mean? Velocity, this is a velocity, and this velocity depends on time. So when you change the time, you will get different values for velocity. So for example, or sometimes you can write this equation this way: velocity at time equal to 10t. So velocity when at 0 time equal to 0, because 10 times 0. Velocity at 1 second equal to 10 times 1 equal to 10 meter per second. Velocity at 5 second or after 5 second equal to 10 times t, which is 5, and 50 meter per second. So this is the instantaneous velocity. This is instantaneous velocity at 1 second. This is instantaneous velocity at 5 seconds. This is how it works. So please repeat what is a derivative. Derivative is a mass, and you should repeat it. What is a derivative and how to use derivative to solve problems. So this is one of the methods to find instantaneous velocity. Now let's explain instantaneous velocity in different way. We will introduce slope. Again, let's draw position time graph. What is a slope? Slope means tangent alpha, or it means gradient. Sometimes we call it gradient. I think tangent alpha is best explanation for you to understand it better, because you know what is tangent alpha, yes, from geometry. So let's say we have this kind of graph, and here we have alpha, angle, and the tangent alpha, sometimes we call it slope of the graph, sometimes we call it gradient. Slope for position time graph will give you velocity or instantaneous velocity. So basically, if you have a position time graph, tangent alpha will be equal to velocity. That's all. That's all. Why? We will explain it here. So we say that tangent alpha equal to velocity. Now we will prove it. And tangent alpha, we call it slope. So how we can find tangent alpha from this triangle? Yes, I will draw it a little bit bigger, this triangle, so you could understand it. From mass point of view, from geometry point of view, tangent alpha equal to opposite side, which is basically x. You should divide by base. Base is time. Yes. So for this graph, tangent alpha equal to opposite side x divided by time, because opposite side is corresponds to distance. The base horizontal part corresponds to time. So what is the x over time? X is a meter, time is a second. So we have a meter per second, which is velocity. So this is a simple explanation why tangent alpha equal to velocity for position time graph. Now we know that tangent alpha or slope equal to velocity. So again, let's draw position time graph. And let's say we have this kind of graph. So what we can say about alpha? And this alpha is always increasing. Yes, for example, here let's say 20 degree, for example, alpha here maybe 40, here it's close to 80, etc. As you see, this angle is increasing, and the tangent alpha also will increase. So it means velocity also increases. This graph corresponds to the motion with increasing velocity. How we can understand that velocity is increasing? Because angle is increasing, and the angle tangent alpha corresponds velocity. Alpha increases, angle increases, it means velocity increases. Of course, you should not forget that if you have only position time graph. If you have position time graph, tangent alpha or slope gives you velocity. When angle increases, it means velocity increases. Let's do some graph examples. Let's study this kind of graph. Again, position time graph, and let's say we have this kind of graph. So what we can say about this graph, this motion? Here, what is happening with this angle? Angle is increasing, yes? This angle is increasing. After some time, it will decrease. Yes, let's say approximately this is a 20 degree, 40 degree maybe. Here again, it decreases, yes? 30 degree. Here angle becomes 0. So velocity basically from this point till this point increases. So let me highlight it with green. So this here velocity is increasing till here because angle is increasing. Then velocity decreases because angle is decreasing here. I will highlight it with red color. Is decreasing velocity. Then what happens at this point? At this point, angle is 0. It means velocity becomes 0 here because angle is 0. Velocity becomes 0. It means this object is at rest at this time. velocity becomes 0. It stops basically. Further, what is happening with this angle? This angle decreases. It becomes negative 30, for example. This angle negative 20, for example. Here again it's 0 degree. What does it mean? Here till this point, from here till this point approximately, angle is increasing in wrong direction, in negative direction, let's say. So basically velocity becomes negative and increasing. It means this object, this car, changed its direction and accelerates to the left direction, to the wrong direction. Velocity increases but in wrong direction, to the left. Again, starting from this point approximately, angle again decreases, increases because negative number, becomes 0. So again velocity decreases because angle decreases and becomes 0. Again at this point it stops because angle becomes 0. Here again velocity becomes 0, it stops. Then this angle remains 0. It means it will not move anymore. This car will stop. It will stop. So this is how you can study the graphs. Let's do one example. A particle's position is given by the function. So we have a particle object which is moving according to this equation, where time is in second. Question: what are the particle's position and the velocity? First question, position is simple, yes, because position equation is given. So solution, position at 2 seconds, we just use 2 seconds instead of time. So minus, so first of all let me write original equation, yes. Then we can continue. Minus t cube plus 3t. So we need to replace time by 2. 2 power of 3, 3 times 2. So position at 2 seconds will be equal to minus 8 plus 6. Position will be equal to negative 2 meters. This is position. Now question, find velocity at 2 seconds. When you pay attention to this equation, you will see that position changes according to this equation. So at this moment, at this point, we cannot say something about this motion because we don't know how velocity changes. So the best way, we need to just derive this equation with respect to time. That's all. V equal to delta x over delta time, or we can say x like this with prime. So minus t cube plus 3t, let's derive it with respect to time, and it will be negative 3t power of 2 plus 3. So this is our equation for velocity. Velocity changes according to this equation. Basically we can say vt equal to minus 3t square plus 3. So velocity at 2 seconds equal to minus 3 times 2 square plus 3. So answer will be negative 12 plus 3. Velocity at 2 seconds equal to minus 9 meter per second. My negative number here, negative sign, means it will be moving to the left direction basically. So it started from here. Let's say this is a x and this is origin 0. After 2 seconds it will be somewhere here, yes, because position is negative 2, and it will be moving to the left direction with velocity 9. With velocity 9, because we had here negative sign, it means it will be moving to the left direction. And let's continue this question, this problem. So question is, draw graphs of x position and v velocity during the interval minus negative 3 and 3. So how we can draw it? First of all, we should find position at this time intervals. So x, we know that equal to minus t power of 3 plus 3t. So x when time equal to minus 3 will be equal to minus 27 minus 9. Yes, so x at minus 3 time equal to minus 36 meters. Yes, no, wrong. Here it should be a positive number, and 27 minus 9, it will be 18, positive 18 meters. In the same way, we should find position at minus 2, position at minus 1, position at 0 time, at 1 second, at 2 seconds, and at 3 seconds. So I will not waste time for these calculations. I will directly write the answers, values. So we have this kind of table. Now we can draw our position time graph. Time, position, here we have a 0. Yes. So at 0 time, no, here we have a 0 meter and minus 3. Here minus negative 2, negative 1, 0, 1, 2, 3. At minus 3 time, position was positive 18. Let's say here we have 18. At negative 2, it was 2. 2 is somewhere here, yes, close to 0. At minus 1, it's equal to negative 2. It's somewhere here. Negative 2. At 0 time, it's 0 here. At 1 second, it's positive 2. At 2 seconds, it's a negative 2. And at 3 seconds, it's a negative 18. So we need to join these dots. Yes, so approximately we have this kind of graph. So this is a graph. Of course, it should be a little bit curved. So this is a graph for position time. Now we need to draw same graph for velocity time. Velocity versus time graph. So again, we need to draw this kind of table again, but for the velocity. For the velocity, we have an equation for velocity which is minus 3t squared plus 3. So first of all, let's write our equation. Vt equal to minus 3t squared plus 3. We need to find when time equal to minus 3, minus 2, etc. Yes, I will do it quickly. So we have this kind of table, and now it's time to draw velocity versus time graph. This is a time. Here we have a velocity. Of course, velocity in meter per second. Time is in seconds. Let's say time starts from here minus 3, minus 2, negative 1, 0, 1, 2, 3. Here 0 meter per second. So at negative 3 time, velocity was equal to negative 24. When time equal to minus 2, velocity was equal to negative 9. Then 0, at 0 time it's 3. Let's say this is a 3 positive. Then again 0, again negative 9, then negative minus 24. So let's join these dots. So we will have approximately this kind of graph. This is a graph for velocity time. So now it's time to practice. I have selected 2 questions for you. Please do question number 5 and the question number 6.